Hello and welcome to this latest Weather and Climate Office Hour. This one's going to be split into two different topics. Hopefully, I'm going to stick to about half an hour or so for each. The first half of the hour will be focused on some late breaking thoughts on the critical national importance of NOAA, the federal agency, and the U.S. National Weather Service, which I strongly believe, and I think is supported by abundant evidence, is an indispensable national public utility, especially in the context of the, quite frankly, rather radical plans and some events that have already unfolded in the federal civil service sector in recent days with regard to wholesale dismantling and disruption of many long-standing federal programs that have provided large-scale public benefits for decades. So that's the first half of today's conversation. And the other half, and this is probably a good summary of the session overall, the weather waits for no one. There is increasingly likely to be a major consequential weather event now in Southern California once again next week, so about 6 or 7 days from now, but this will be very different than the recent consequential weather events, which have been mainly fire weather related. This one will be a potentially very strong, one-off, but potentially quite strong storm that could bring very heavy rainfall in areas quite severely affected by recent wildfires. So, unfortunately, I was hoping we might get through this winter without any really intense rainfalls in the fire zones. Unfortunately, this might well be exactly that. A brief but very intense rainstorm that could cause significant risk of flash flooding and debris flows, particularly, though not exclusively, in the areas affected by Southern California wildfires. And not just the January fires, which of course affected many people very severely, but also the September fires, which affected still quite a lot of people, but importantly occurred in much steeper and more mountainous terrain, all of which is above highly populated areas, ultimately downstream. So those are the two topics for today. I'm going to start by talking in the first 30 minutes about NOAA. So I also wanted to refer folks back, and I can share a link at the end, or if somebody shares a link in the chat, actually, that would be helpful. I talked about this in early November 2024, just before the presidential election, reflecting on how I think the importance of a lot of federal agencies that do not just science for the sake of science, although, of course, that is still valuable, but applied science effectively in direct and quantifiable service of society and the nation at large, the general public at large specifically. And NOAA is one of those agencies, and specifically the National Weather Service, which is housed within NOAA. NOAA is an agency within the U.S. Department of Commerce, and the National Weather Service is yet a further subset of NOAA. And the importance, I think, of the Weather Service in the U.S. as it is today cannot really be understated, or cannot be overstated, excuse me. And I think that a lot of folks don't necessarily recognize just how critical the services and just how irreplaceable, and I think this is the key word, the services that it provides today are. And so I want to talk a little bit about what the private sector can and cannot do in this space, and why, if we break something like the Weather Service, even temporarily, even if the goal is not to actually dismantle it, but just to sort of freeze things and reassess, that it could produce catastrophic damage not only to the agency itself, but the ability of the United States to anticipate, prepare for, and respond appropriately to disasters, and how even a temporary interruption of these services would have cascading effects that would very likely result in the deaths of Americans who otherwise would not have died in extreme weather events, and extensive harm to the economy that otherwise would have been or could have been avoided. So the stakes are high. And there are, of course, other reasons why we should care about all of these things. Certainly, that's what I believe. But even if you just want to quantify it in terms of death tolls in dollars, there are very specific reasons why it's extremely dangerous to play around with things that cannot be easily fixed if broken. And so the ethos of move fast and break things, that's long been a saying sort of in the Silicon Valley world, it works pretty well for in certain settings. You know, if you're a high risk, high reward startup trying to build something, I can see the value in that kind of philosophy. Sometimes you have to take risks and think outside the box, and I don't think that's always a bad thing. In fact, in many contexts, I think it's a positive attribute. But one place where it is really dangerous is in institutions that provide critical services to hundreds of millions of people 24 hours a day, 365 days a year, and on top of which are layered virtually all of our other systems. They are coupled together in ways that are not obvious to, I think, the outside view in all cases, and in ways that I think are often underestimated. So I just want to talk a little bit about the context for this. We know that there has been unprecedented level of direct interference in the operations of many federal agencies and federal departments over the past couple of weeks. And now, as of this week, that has begun to extend to NOAA. It is unclear exactly what the end goal is in a lot of these cases, but we know that just a handful, literally 3 or 4 people, private contractors with no formal government affiliations and under conditions of genuinely dubious legality. I'll leave that to the lawyers and constitutional scholars to argue. It's not really my main point today, but this is the result of just a literal handful. You can count on potentially 1 or 2 hands the number of people who are implementing these radical changes without really articulating the end goal by essentially plugging in their own private servers and taking over the computing infrastructure of large swaths of the federal government. Most recently, this has apparently happened within NOAA. And there have already been large layoffs in certain sectors, or funding freezes or pauses or threats of further layoffs and further cuts, dramatic ones. In fact, the National Science Foundation is said to be facing, and again, there's very little, if any, transparency on this, which is a bit ironic given the stated goals of the pseudo-governmental informal entity known as DOGE, the Department of Government Efficiency, although it is not a department and it does not appear to be focused primarily on efficiency. But I have personally seen a lot of the emails, as many of you have. They've leaked out pretty widely. Some of the emails that have been going to government employees, including NOAA employees, USGS employees, Department of the Interior, NIH, CDC, and they're quite personally insulting, essentially arguing that government employees are inherently lazy and should get a higher productivity job in the private sector. Anyway, so morale is extremely low, bottoming out near zero in a lot of federal agencies right now. But the more urgent problem in some ways is the concern that moving fast and breaking things in terms of things like, air traffic control or extreme weather hazard prediction, it's really not something you want to break because you need it to be operational 100% of the time. And so tearing things down to build them back up in this context simply isn't reasonable, safe, or logical, really. And I'm going on a bit on a limb because we don't know exactly what's going to happen. And a lot of folks have argued, well, has NOAA been dismantled? Is the Weather Service still providing forecasts right now? Yes, it is. And NOAA has not been dismantled yet. I think yet is doing a lot of work in that sentence. And I also think it's appropriate to talk about these things before it happens in the hopes of preventing it from happening rather than lamenting what we've lost once it's gone. Because as I've mentioned, it's vastly more difficult, if not impossible, to rebuild these entities if they're gone. And by gone, I don't necessarily mean zeroed out, disappeared off the face of the planet. These are agencies where freezes on communications, so various NOAA employees are not currently allowed to speak or correspond in an official capacity with anybody outside of the United States. So all international communications have been cut off. Well, I'll tell you one thing, the oceans and the atmosphere, the fluid ocean and the fluid atmosphere certainly do not obey political boundaries or international borders. So to the extent that that may or may not extend to weather and climate operations, and we don't know because there is intense secrecy involved in these decisions, that would immediately inhibit the ability to produce the best weather forecasts and the most appropriate weather warnings. But even if there's a substantive defunding or a substantive personnel reduction in many of these cases, I think people forget that these are often agencies and operations running on bare bones staffing. These are entities that need to be staffed 24 hours a day, 365 days a year. Again, this is something where there are more parallels between operational weather prediction and air traffic control than perhaps many folks would like to admit. You can't really accept any major failures, and you can't really afford any substantive downtime because the weather waits for no one, and also air traffic is always up there, whether or not it's being controlled. And I think that the real risk is that I don't think there's a widespread understanding of what the Weather Service does and what it doesn't do and how it's not replaceable easily. NOAA and the Weather Service are not equivalent to the meteorologists, for example, you see on the evening news. It's not to diminish broadcast meteorologists in any way, and in fact, there has been an outcry from broadcast meteorologists, including those on the Weather Channel and at AccuWeather, for example, all of these private weather companies that you might be familiar with, pointing out that all of these private weather enterprises is built upon the public backbone of data. AccuWeather does not have their own fleet of satellites and weather radar and ground stations. They do not operate their own weather predictive models for the most part. They're either taking data directly from NOAA or equivalent agencies around the world, or taking that data and then adjusting it in some proprietary way. But fundamentally, those models are not being run at AccuWeather or at the Weather Channel, with some minor exceptions now. It didn't used to be the case at all. There's some minor exceptions today. But the data, the observations, the satellite imagery, the radar imagery, I don't think a lot of folks realize where that's coming from. And in the United States, that is coming from NOAA and the National Weather Service. And in the case of satellite data, partnership between NOAA and NASA. That data is essentially all freely available for the private sector to use. It's funded by taxpayer dollars. And there's a reason for that. The reason for that is that the accurate prediction of weather hazards, and even just ordinary weather, is a multi-billion dollar enterprise in terms of the potential losses averted or the costs involved. And it's estimated very conservatively, and I use that with the lowercase c conservative, the traditional form of the word, that the National Weather Service, specifically within NOAA, produces benefits within the U.S. that are on the order of 10 at the low end, and in some estimates as high as 100 times the cost of operation. Imagine a machine where you put in a penny and out comes a dime, or better, put in a penny, out comes $1. I want to find that machine. That's essentially the return on investment that we get from high quality weather prediction based on how much it costs to produce it in the US. So It's a huge, massive public benefit that costs Americans on average about $3 per person per year to operate and produces tens to hundreds of billions of dollars in benefits and saves what are arguably thousands of lives a year. It's a little bit difficult to estimate the counterfactual, but that seems like a likely range. There are some years where the number is probably fewer lives saved, but perhaps other years where it's an even greater number. So I think that's a safe intermediate number. So tens to hundreds of billions of dollars a year saved in terms of the national economy, and hundreds or even thousands of lives saved every single year for an investment that costs the average American about $3 a year. I don't even think you can get a nice coffee in most American cities for $3 anymore. Anyway, the reality is that this is an immensely beneficial public good, a public utility, I think it's fair to call it. And if it is substantively disrupted, even through something like a 20-30% funding cut, for example, or a mandate that it must commercialize its weather services, no longer offering that data for free to the public or to private companies, that would greatly diminish the efficacy of the service. If they close local weather service offices, again, the National Weather Service has both a national superstructure based in Silver Springs, Maryland, so essentially DC area, as you might expect, but also field offices all throughout the country in strategically located areas, including field offices in places like Hawaii, multiple field offices in Alaska, and there's also one in U.S. territories. There's an office in Puerto Rico. There's an office in American Samoa. So this is an agency that has a lot of local expertise, which is invaluable when it comes to communicating with people on the ground in specific locations, understanding the local risks and hazards and the kinds of phenomena and behavior that are common in certain places, developing relationships with local government officials and emergency managers and farmers and firefighters and all of that. Ultimately, no matter where you live in the U.S. or its territories, you can essentially call at a phone number and reach a meteorologist paid for with your tax dollars at the National Weather Service who's familiar with the weather in your local area. Think about that for a minute. That's not a trivial thing by any means. So consolidating to get rid of those field offices and put everybody in regional offices, or worse, move everyone back to DC, makes no sense. Much of the value, in fact, of the U.S. National Weather Service, as opposed to other national meteorological services, is the degree of local expertise that is inherent to a distributed system geographically. Other countries don't have that. It's just not a thing that exists. Even in many countries where there are objectively good meteorological services provided by the government, it's often centralized, and there just isn't the same level of local expertise. And to be quite honest, the U.S. is a big and geographically diverse country. I mean, think about the difference between the Arctic Ocean coast in Alaska, or the subtropical oceans of Hawaii, or the mountains of Northern California, or the Northern Rockies, versus the Great Plains, or the Everglades in South Florida, or the Eastern Seaboard. These are radically different geographies, climates, and local contexts. So it makes sense that we have this distributed system, and largely it has worked well. And I'm not going to, by the way, defend any particular line item expenditures. Folks are saying, well, surely there's waste everywhere to be found. And honestly, that's probably true. There probably are inefficiencies peppered all throughout the federal government. I'm not arguing with that, and it's not really my place to argue with that. But I think the real question is the scope of those inefficiencies outweighing the public benefits that's provided by these various entities? And I think that extends beyond the Weather Service and beyond NOAA to other agencies, the NIH and CDC. And I think the answer is clearly yes, the public benefit, even given that there probably are inefficiencies. I don't doubt that. And sure, maybe we can address some of those and have a slightly leaner operations. I don't think that's necessarily a bad thing, but I also don't think that's actually what's happening here. This just seems like an excuse to defund any number of critical public utilities and services that provide benefits to hundreds of millions of Americans. And I just wanted to illustrate the one that I have the most relevant domain expertise to opine on again, which is essentially NOAA and the National Weather Service. And just to point out that if we lose this, the private sector cannot step in tomorrow or next week or next month or even next year and replicate. If NOAA stops providing these services or provides them in a diminished or reduced or commodified way, we will discontinuously lose access to what we've taken for granted for decades, which is the ability to know if a devastating storm or extreme wildfire risk episode, for example, is headed your way. I'm going to talk about something that's enabled right now by good weather predictions in the next half an hour. A specific example, giving a weak warning to folks in Southern California who might need to do something to stay safe during next week's events. The Weather Service in the U.S. is the entity that makes that possible in large part. And the private sector, again, not to malign the private sector, there's a lot of value there too, and there's space for both. And perhaps there can be broader public-private partnerships, and maybe even I think there should be moving forward. So I'm certainly not anti-progress, anti-efficiency by any means. In fact, if you knew me in my personal life, I've been tearing my hair out over essentially what are effectively tremendous inefficiencies, ludicrous inefficiencies, if you will, in both public and private sector systems that I have to interface with on a daily basis. So I'm very sensitive to that. But I'm also very sensitive to people pretending that that's what they're trying to achieve when really trying to achieve very specific ideological aims. And since I'm getting close to the half hour here, I'll try and wrap up soon so I can talk about the event that is probably of interest in Southern California during the second half of this session. But one thing I wanted to emphasize, and I will post a link actually to this talk or the live stream that I gave back in November where I reflected on this at greater length, actually. But I just wanted to close with this. There's one part of the Project 2025 document, which I think despite a lot of protestations, it's quite clear this is now a defining policy document that is guiding the current presidential administration's actions in its early weeks. In fact, everything so far has been in almost chronological order in this document. NOAA and the Weather Service are mentioned next, and that does appear to be where there are changes going on right now. But this is something I think a lot of folks missed back in November, and for me, having read most of this document, it's actually one of the most disconcerting statements that I found in it. And I'll just read it, and this is a verbatim quote, by the way, from the original Project 2025 document, whose architect, by the way, was approved by Congress yesterday to essentially have the power of the purse when it comes to the executive branch. This would be Mr. Voigt. And this is a direct quote from the document, by the way, from Project 2025, as it was in the year 2024. This is in the section describing preferred and desirable changes to NOAA and the National Weather Service, and it reads, this industry, in other words, the weather industry's emphasis, or the climate industry's emphasis, this industry's mission, emphasis on prediction and management, seems designed around the fatal conceit of planning for the inevitable. And I emphasized this back in November, and I'll read it again because I think this is critically important for understanding what we're seeing evolve. Not just in NOAA and the Weather Service, but I think even more broadly in terms of things like trying to prevent the emergence of pandemics, trying to preemptively avert geopolitical conflict. These are the kinds of agencies we've seen massive disruptions in already. And I think this one sentence encapsulates, in a lot of ways, the guiding philosophy as to why. This industry's mission emphasis on prediction and management seems designed around the fatal conceit of planning for the unplannable. The fatal conceit of planning for the unplannable. That is, in a nutshell, the entire point of weather and climate prediction. Why do we bother to predict the weather at all, if not to predict the future, to manage the what would otherwise be unmanageable? That is the whole point, to avert harm, to prevent as much harm as possible to as many people as possible. Harm not just meaning, death and injury, but also harm to the economy, dollars, since that seems to be such a central focus right now. This does extend to preventing economic harm, people losing money, stock market crashes, regional economic disasters stemming from natural events, natural hazards that were poorly predicted, weather disasters or otherwise. COVID pandemic certainly didn't do any favors to the global economy, did it? Would it have been better if either we didn't have the pandemic or had it been managed better? Yes, it would have been better for the economy. It certainly would have been better for the millions of people who died or who have now long-term chronic health conditions stemming from it. So I don't understand. I personally and professionally simply do not understand the idea that we shouldn't try to predict the future. We shouldn't try to anticipate the big bad things that could happen, because the whole point of doing so is to either prevent them from happening to the extent that that's possible, or at least to mitigate the damage that occurs when they do. Why bother? Why do science at all if not to improve humanity and to prevent bad things from happening and try and encourage good things to happen? What is the point of predicting the weather, even on a very mundane basis? If there's a chance of showers tomorrow, you might bring an umbrella. Is that planning for the unplannable? I think I'll leave it at that. But I will share a link to that conversation that I had back in November, which I think may be enlightening for folks who might want to follow it, or essentially see my deeper thoughts on this. And you see me going off screen because I'm just trying to copy and paste that link directly into the chat right now so people can see it. So here is that. And I will take a quick look at some of the questions right now before I jump into talking about potentially significant storm and therefore, unfortunately, flash flood and debris flow risk in Southern California in the post-fire environment. So I have posted that link. You can see it now. Okay. One other note, by the way, a bit of an intermission, I'll answer some questions. We do have a rapid response paper out in Global Change Biology. We were actually invited to write this following the LA fire, so this is record turnaround, less than a month from the invitation to publication. It's not a full peer-reviewed analysis, of course, it's far too rapid for that, but we do offer some quantitative statistics regarding the broader context surrounding the LA fires, hydroclimate whiplash, and the settings in which that will matter in a warming climate, where these alternations between extremely wet and extremely dry conditions will increase the risk of wildfire globally more than just simply looking at changes in the background aridity state might otherwise. So feel free to check that out. It's only 2 pages. It's written for a general audience. There's a couple of very intuitive, hopefully, time series focused on hydroclimate whiplash specifically in Southern California and extreme fire weather conditions during Santa Ana wind season. Thanks to co-authors for helping me turn that around very quickly. That link, again, it's open access and it's right up at the top of the chat today. And also wanted to take a moment just to remind folks that this channel is sponsored by Reask, climate tech company that's helping to rethink extreme weather risk in a warming world and helping companies to manage it. And right now I'm only taking questions on the first part of the discussion today. I'll take questions again at the very end on what might unfold in Southern California next week. There is a related question from Jen regarding the 2 billion plus gallons of water that were released from 2 dams in the southern Sierra Nevada earlier this week by the Army Corps of Engineers. So again, there are some dams in California, many dams in fact, that are not operated by the state of California, but are actually operated by the federal government via the Army Corps of Engineers, whose primary task is flood risk management, and then secondarily responsible for some other aspects of water management. These were apparently, and again, I was a little bit skeptical, astonished really, that this is actually why what happened, but this has now been confirmed in reporting, as that there was a direct order from the executive branch, so from the President of the United States, to the Army Corps to, quote, release as much water as possible. I think this may have been in an attempt to make it look like something was being withheld from Southern California in terms of firefighting efforts. Of course, anybody in the firefighting or water world knows that that's not how any of this works. There was no lack of water in Southern California. In fact, the reservoirs there have been at above average water levels this season, the legacy of 2 previous wet years. But this release of water apparently was going to be at maximum channel capacity downstream from these dams that drain into the Tulare Basin in the southern San Joaquin Valley. There was great alarm among flood managers, water managers, and farmers, as well as residents in the region, because there was essentially no warning. Usually this is a very coordinated process because there can be significant flooding that results from rapid releases of water, especially if they're unexpected. And there's always a risk of essentially exceeding channel capacity and blowing out levees in the riverbank. So if you do release water at maximum channel capacity, that's usually an emergency measure to prevent worse flooding. It's not something you do for politically expedient reasons. At least it has never been historically. That appears to be what happened in this case. And I think the greater fear is now the Army Corps partially relented and released water at a lesser volume that was less dangerous, although still required emergent evacuation of people from the river channel who did not know the water was coming because the usual channels were circumvented. There was no widespread flooding because they did not ultimately release it at full channel capacity as originally planned after pleas from essentially farmers at the in the Central Valley. But the challenge is that this sort of upends the decision-making process. That's the big concern. Who was in charge of emergency water releases from Army Corps-operated water infrastructure in California at this point? Is it subject to political pressure versus dam safety or flood safety? That is a real concern. And in this case, there was no severe harm. It doesn't look like there's any ongoing problems right now. And honestly, I don't even think that the water necessarily was quote-unquote wasted in the same way that some people think it was. Ultimately, it probably just went into the groundwater in the San Joaquin Valley for the most part. Some of it evaporated, some of it probably soaked in. But I think the real reason why this is a problem is it really raises the question of who's in charge, and can we rely on entities like the Army Corps to operate this infrastructure solely with public safety in mind? This was not a water release that was intended to preserve public safety. Let's put it that way. So we have a sample size of 1 at least, where we know that that is now not the only consideration at play. That's my perspective on this. Just looking at the remaining questions here, and of course I won't be able to answer all of them since I do want to get to the other part of this conversation today. All right. And I think a lot of folks are reflecting that there is a great deal of fear and uncertainty in the federal government, and that I have a lot of colleagues and others in my life who certainly have expressed that. And I've seen some internal communications from different agencies, and they're pretty horrifying, to be quite honest. Very unprofessional. I guess to put it very mildly, I think for some folks who've been in civil service for 30, 40, 50 years, it is shocking to receive such inappropriately demeaning and informal messages, at the very least. And I do think that's at the very least of the problems in this case. There's a question. Laurie says, Daniel, can you recommend alternative sites if NOAA and the Weather Service get shuttered? For example, Tropical Tidbits. Will this be reliable without NOAA and the National Weather Service? Well, I can answer that pretty succinctly. No. All of the alternatives, they're all based on NOAA data and the Weather Service. None of them would be operable for the most part. There are some European data sources. There is the European Weather Model, for example, the ECMWF, but even that, where do you think the observations for North America that go into that modeling framework come from? You guessed it, it's primarily almost exclusively from NOAA. And all those other tools would be completely gone because all of them are ultimately operated by NOAA. So all these plots I show from Tropical Tidbits are either coming from NOAA directly, they're replotted on a website like Tropical Tidbits, or it's the European counterpart, which is itself semi-dependent on what comes from the United States. The other thing that's worth noting is that ECMWF data, so the data from the European equivalent, is not free. In fact, it is so expensive that many academics that I know do not always have the research budget to obtain the data. So I pay annually for multiple subscriptions so I personally can give the public access to these European data sources in some cases. It's at a minimum, just for personal use, it's in the hundreds of dollars per year. For professional use, it's into the tens of thousands of dollars per year per person for data licensing. So compare that to the $3 a year of your taxes that go toward NOAA. And that's I think the direct point of comparison. So food for thought. And it's also worth noting that most of the AI weather data platforms also ultimately use NOAA or ECMWF data as their baseline for that modeling. So none of these are independent data sources, and I don't think anybody really recognizes this who are in positions, unfortunately, to blow things up. All right, so I think I'm going to wrap that portion of the discussion up and now going to talk about the potentially significant weather event in Southern California next week. So just a brief summary, it's been raining in Northern California this week, and in fact, some of these systems have overperformed. There has been some notable flooding locally, not widespread, not catastrophic, but it has been locally significant and arguably worse or more than expected in some settings. And by that I mean the Pitt River up in far northeastern California reached major flood stage for the first time in a number of years this week. Not any huge population centers up there, but that's still notable. There was also considerable flooding along the northern part of the I-5 corridor in the northern Sacramento Valley. Some significant flooding down into Yolo County as well as in pockets of Sonoma County. Again, nothing catastrophic or hugely damaging, but definitely caused problems and some localized evacuations, and notably, it was a bit more than had been originally predicted. And I think that's partly because Some parts of Northern California still have the hydrologic and soil moisture legacy of what was a record wet November and December period, literally the wettest such period on record in some places. That legacy, despite a very dry start to January, for most of the month in fact, made a pretty big difference, and those rivers and streams came up very quickly in response to rain that was heavy but not unprecedented, but the rivers responded very, very quickly. So that's sort of setting the stage for what's happened recently. Southern California has gotten a little bit of water, but nothing all that dramatic. The rain has been pretty light and mostly beneficial in Southern California. There's been some minor rock slides and debris flows in the fire zones, but certainly nothing to really write home about in the scheme of things. And I think it's worth sharing my screen now, since I want to show some data. You've been looking at my face for the better part of the hour, so let's give everyone a break. Okay, so the first thing I want to show, hopefully this will be satellite imagery that everybody can see when it comes to the full state of California. I'm just double checking that this is what everyone's seeing. Yep, okay. Bring out my drawing tool here. So this is current satellite imagery in California. Where did my drawing tool go? It has disappeared. There it is. So you can see the low, whoops, that's not what I want. I want the free draw tool here. So you can clearly see the low pressure system here with the swirl like this. You can see some clouds in Southern California. There's some scattered showers in this region still, but it's starting to clear out. It's a pretty day with some popcorn cumulus clouds. I don't think any of these are deep enough for thunderstorms probably, but some localized downpours maybe. This is the remnants of the system from earlier this week. This is, at this point, what remains is essentially beneficial. Nothing too dramatic going on. But next week, the situation may change somewhat, particularly in Southern California. So going over here again, I'm using the European model, but because it is a somewhat better model due to lack of investment in the American model in recent years. That's, well, maybe not a story for another day, but a parallel story to what I was talking about earlier. But in any case, this is the most recent model cycle update showing this is right now. There's some scattered showers around, nothing too dramatic. They will end by tomorrow. A dry weekend for the most part in California. Dry and neither particularly warm nor particularly cold. So a pretty unremarkable early February weekend in most parts of California. Then look what happens as they start to go toward the middle of next week. The active pattern returns first to Northern California and Central California around next Wednesday. But next Thursday, this is where the big concern is mainly on Thursday, look at what we start to see in Southern California. That's a very, very heavy rain event associated with a strong cold front and atmospheric river with very warm subtropical air associated with it. That's very, very heavy rainfall potentially in the transverse ranges of Southern California. So a short, sharp burst from Santa Barbara, Ventura, LA, San Bernardino, and Orange counties. And of course, all of those fire areas that we've talked about from September last year to January this year are, well, they're all pretty much in this exact part of California. So this is a concerning pattern. If this forecast were to pan out as we currently have, about 6 or 7 days from now, there is the risk of significant or even major flash flooding and debris flows, particularly in the fire zones, but even locally elsewhere. These are high numbers, but the primary concern would definitely be in the fire zones. That system moves out fairly quickly, so it's not a prolonged storm, but again, if you look down in Southern California, that still could be on the order of 3, 4, 5, 6, 7 inches of rain in some of the mountain areas over just a day or so. That's the basis for concern. There could also be some heavier precipitation in the Southern Sierra or the coast ranges, the Monterey County Highway 1 coast region, but the real concern is down in Southern California due to the recency of the fires. Now, if I compare it to the American model prediction for the same period, it's pretty wet, but it's not nearly as wet in Southern California. In fact, it's about half as wet or less than the European model. So there's a significant divergence here, and if I look at the ensembles for both of these, for the European model here, pretty wet for Southern California, and the American model, again, this is not, here is the, there we go, much drier for Southern California. This would not really pose a major flood threat. So there is a significant gap right now between the American and the European model ensembles. Which one will win? The European ensemble would suggest a pretty high likelihood of a concerningly heavy rain event that could cause big problems. The American model ensemble, much less so. But let's take another look at that. Here's what the European model shows for a point near Los Angeles, which is nice and representative, I think. But here, actually, maybe I will take a look at a point in the mountains of Southern California. So this is now Big Bear City. It actually doesn't look all that different. The model topography is a little bit messed up. But anyway, the main point is this. When we look at this high confidence in this event, so as we go from left to right and go forward in time with prediction, as we go from top to bottom on this plot, each of these going left to right is a different ensemble member, so a different permutation of the same European model with slightly different initial conditions. And you can see that almost every iteration of this produces significant, if not heavy, rainfall in the mountains of Southern California right around next Thursday, so about 6 days from now. But there's a pretty wide range. Look at this member, for example. 0 precipitation. The storm completely misses Southern California and it stays completely dry. Wouldn't that be something? On the other hand, take a look at this ensemble member. I guess I'm covering it here, so I'll let it go. But look just above it, above the line. 4 or 5 inches of rain in a day. That could be a big problem. Note also that there's really not any rain in the forecast between now and then, nor really much, if any, after. So potential is quite high for a significant one-off storm next week. It won't produce widespread flooding elsewhere, but it could be a big problem for the recent wildfire burn areas that are particularly susceptible to high-intensity precipitation. I'll go back to the European model depiction of this because I want to zoom out to the North American zone. Of course, just to reorient folks, here is California on the map. But I want to show something different in this plot here. Uh-oh. I have a little too many tabs open. Let's see. Okay, so we don't have it at this view. Let's see. Northern Hemisphere, do we have the moisture here? Just trying to find the right plot to show the atmospheric river coming all the way into the western US. Maybe we'll do it this way. So there's that atmospheric river depicted by the European model ensemble heading into transverse ranges of Southern California. The details won't be clearer for a few more days. If this happens, I'll probably have a blog post next week to talk about it, as well as at least one more live session. But this does not look like a particularly concerning storm in Northern California. It's still going to rain, potentially heavily, but most of the heavy rain next week will not overlap with the area that got the heaviest rain this past week, so that's good. It really is a question of these burn areas being highly susceptible and this storm having the potential to produce pretty high rainfall rates. But there's a range of uncertainties, as I showed, all the way from near zero precipitation to very heavy precipitation causing big problems. So I'm going to bring my face back on screen because I think I've shown most of what I need to show quantitatively on the data side today. All right, so I'm going to answer, take a look at the remaining questions. So take a sip of water and bear with me for just a minute. All right, here. Comment, there was a bit of street flooding, or quite a bit of street flooding in Davis last night. I have heard from folks that Yolo County was a bit of a focal point for some urban and stream flooding that locally was significant over the past 48 hours. Yeah, I am concerned about the hills above Altadena and Pasadena. Also, the Pacific Coast Highway and western LA County, so Malibu, Pacific Palisades, is probably going to be a mess. I think the PCH is actually closed to the public indefinitely at this point, not due to fire damage, but actually due to the risk of debris flows and mudslides just being too high to allow the general public in the area, which at this point, I suppose makes sense, at least till after this next storm does what it's going to do. But there are other areas. Again, there were major fires in September in the San Gabriel Mountains, up by Running Springs, Wildwood. These areas are potentially at risk, depending on where they are relative topographically to whether the watersheds were above or below them in a vertical sense that were exposed to the fire. So more details next week as that evolves. All right, well, not too many additional questions right now. I have another minute or two, so I'll stay on, and if anything else comes through. But I think the real challenge in communicating a lot of these hazards, both in California and elsewhere, is that they're locally specific. Just because your area didn't get a lot of rain doesn't mean someone else did. And the reverse is also true. If you're seeing flooding in your backyard, in this case this week, as happened with some folks, it does not necessarily mean it was a big rain event or a flood event statewide. It is a big geographically diverse state, and your mileage may vary. Literally, there's a lot of mileage to cover in a state as big as California and a state as geographically diverse as California. So there have been, interestingly, during this most recent week, places as low as about 1,500 or 2,000 feet in the coast ranges of Northern California that have been getting snow. Even places in the northern Sacramento Valley down by 1,000, 1,500 feet elevation that have been getting some snowflakes, while Lake Tahoe has been seeing rain. It's been too warm for snow. That's kind of a weird setup. And it has partly to do with the position of the low pressure system, where the warm and the cold air are getting advected. Advection means the movement of a quantity by the wind. In this case, the quantity being the air of a certain temperature. In this case, warm air, relatively speaking, into the Tahoe region, and colder air on the backside of the low in northwestern California. But I think I think a lot of folks who participate in these live sessions have a fairly good intuitive sense of how this works, but it's always worth emphasizing in cases where that might be less obvious. All right, there's one question at the very end. It's a good one, and so I'll answer it before signing off for the day. Rick asks, you mentioned the different ensemble members having different initial conditions. Shouldn't they all start out with the same present conditions? Thanks. You might think so, but the reality is we don't know, as I've discussed in the past, exactly what the present conditions are exactly. Do we know the exact temperature, pressure, and wind at every level of the atmosphere, everywhere throughout the globe in the 3D vertical atmosphere, all the way from the surface up to 50,000 feet? We do not. We have decent estimates of those things from satellites and from models themselves, but we don't know precisely exactly what the state of the world is in this exact moment as I'm talking to you now. Because of that, there is always uncertainty, sometimes not more than trivial uncertainty, in what the correct initial conditions in this time zero initialization moment actually is. And so because of this, we actually don't know if our best guess of the way the world, the initial conditions are right now, is the most correct version of what the real world actually looks like right now. And so that is essentially the wisdom behind a perturbed initial condition ensemble, which is that we take our best guess of what the world looks like at time zero, the initial time from which all predictions move forward from. That is the first ensemble member generally, so that we do use that is one of the members is our best guess. But because we don't know if that member is actually truly the closest to the real world conditions, we deliberately add some noise, some intentional variation, not a lot, just a little bit, to those initial conditions to account for the uncertainty. So we emulate the range of uncertainty in those initial conditions. And the larger the ensemble, the more finely we can quantify our estimate of the range of that initial condition uncertainty. And so all of these predictions are then very sensitive on the initial conditions. These tiny, sometimes almost infinitesimal variations in the initial atmospheric conditions, noise essentially, small amounts of random noise in those initial conditions. That is what cascades in all of those predictions that I showed you to produce sometimes vastly different outcomes. So recall that there was one ensemble member I pointed out, only 1 out of 50, so it's unlikely, but it was 1 out of 50. And it's the exact same model, essentially, in all of these members. One of those 50 ensemble members for LA brought 0.00 inches, no rain at all, during next week's potentially major storm event, whereas other members, in fact most members, are quite wet. Although there's a handful of members that are extremely wet and a larger number of members that are more moderately so. All of those members are the same atmospheric model using very slightly different initial conditions. And so you can see where I'm going with this. That's why it's important to do so, because we don't know which of those randomly perturbed initial conditions is closest to the real world. And because we don't know, we usually treat each of those members equally, as they're each essentially equally plausible. And so that is how we make predictions. That is how the skillful meteorologists, for example, at the National Weather Service, make predictions, qualitative predictions stemming from these quantitative data points. And by the way, most of your smartphone weather apps don't do that. They just use one ensemble member randomly selected from the group. And that is why, arguably, they're terrible in many cases. And it also, and this is quantitatively true, this is why the forecasts on your smartphone weather app vary so wildly 4 or 5 times over the course of the day. It's because they're randomly selecting a model member each 6-hour update cycle, usually the control run, but for all intents and purposes, that is a randomly selected member from among the broader ensemble. And that can change quite radically. The member that the last model update cycle was the dry one could become the very wet one. What you really want to do is look at the big picture. Look at the full distribution of the ensemble and look at what it's telling you, like we just did today. And what it's telling us for Southern California next week is that there's a pretty high chance of a heavy rainfall event that could threaten flash floods and debris flows in the recent fire zones, but that there's also fairly high uncertainty and that there's differences between the models right now. That to me is more interesting than the difference between members. The fact that the European ensemble is different, wetter, than the American ensemble. The European model and the American model are actually different models, and it is likely that one or the other of them in a given situation probably is a better model. On average, these days, that's the European model, but that's not universally true. So it'll be interesting to see how that evolves next week. All right, folks. Again, a few just points of order. I do encourage folks to check out both our new rapid response paper in Global Change Biology on the LA fires in the context of hydroclimate whiplash, specifically for Southern California. That link is up at the very beginning of the chat, and if you missed it, I will also shortly be writing a thread on all social media platforms in the next couple of hours about it. And also, if you want my expanded thoughts on Project 2025 and the critical importance of NOAA, and in particular the Weather Service, not to diminish the rest of NOAA or other federal agencies, but really just honing in on this one specific thing, the Weather Service, and its incredible importance in the U.S., please do also check out my conversation from just prior to the November 2024 election. I also added that link in the chat here, but we'll add that link embedded at the end of the video once this is available. The recording is available online in about half an hour or so. All right, everybody, thank you, and I'll talk to you next time. Next time being at some point next week, probably to talk about the storm in Southern California and its potential impacts once again, once the picture becomes a bit clearer. Thanks again. Have a good weekend, and talk to folks later.